Hi student, let's try to understand the topic advanced sunrise and delayed sunset. The sun is visible to us about 2 minutes before an actual sunrise before the actual sunrise and about 2 minutes after the actual sunset. Because of atmospheric refraction by the actual sunrise, we means that actual crossing of the horizon by the sun shows the actual and apparent position of the sun with respect to the horizon. The time difference between the actual sunset and apparent sunrise is about 2 minutes. The apparent flattening of the sun disk at sunrise and sunset is also due to the same phenomena. So when it is horizon, what it do student, it get refracted towards the normal in denser medium. So it appears early student. Person is busy viewing here, but it is actually it is here. This is what apparent position and this is actual position. Here you see student what is the atmospheric refractions. You might have observed the apparent random weaving of flecking of objects seen through a turbulent stream of the hot air rising above the fire or a radiator. The air just above the fire become hotter than the air further up. The hotter air is lighter than the cooler air above it and has a refractive index slightly less than that of the cooler air. Since the physical condition of the refracting medium are not stationary, the apparent position of the object are seen through the hot air fluctuates. This waving is thus an effect of atmospheric refraction. Refraction of light by the Earth's atmosphere on a small scale in our local environment. The twinkling of stars is a similar phenomena on the much larger scale. Let us see how we can explain it. Twinkling of stars. The twinkling of star is due to the atmospheric refraction of the starlight. The starlight at entering the Earth atmosphere undergo the refraction continuously before it reaches the Earth. The atmospheric refraction occurs in medium of gradually changing refractive index since the atmosphere bends starlight towards the normal. The apparent position of the star is slightly different from the actual position. The star appears slightly higher than the actual position when viewed near the horizon. Further, this apparent position of the star is not the stationary but keeps on changing slightly since the physical condition of the earth atmosphere are not stationary as was the case in the previous paragraph. Since the stars are very distant, they approximate point size surface of light as the path of the ray of the light coming from the star goes on varying slightly. The apparent position of the stars fluctuate and the amount of sunlight entering the eye flickers. The star something appears brighter and at some other time fainter, which is the twinkling effect. Why does the planet twinkle? The planets are much closer to the earth and are thus seen as extended source. If we consider a planet as the collection of large number of point-sized sources of light, the total variation is the amount of light entering our eyes from all individual point-sized sources will average out to zero, thereby nullifying the twinkling effect. Scattering of light. The interplay of light with the object around us give rise to several spectacular phenomena in nature. The blue color of sky, color of the water in deep sea, redness of the sun at the sunrise, and the sunset are some of the wonderful phenomena we are familiar with. In the previous class, you have learnt about the scattering of light by the colloidal particle. The path of the beam of light passing through a true solution is not visible, however, its path becomes visible through a colloidal solution where the size of the particle is relatively larger. Tyndall, the Earth's atmosphere is a heterogeneous mixture of the minute particles. These particles include more smoke, tiny water droplets, suspended particle of the dust molecule of air. When a beam of light strikes such fine particle, the path of beam becomes visible. The light reaches us after being reflected diffusely by these particles. The phenomena of scattering of light by the colloidal particle give rise to Tyndall effect, which you have studied class 9th. This phenomena is seen when a fine beam of sunlight enters smoke-filled room through the small hole. Thus, scattering of light makes the particle visible. Tyndall effect can also be observed when the sunlight passes through the canopy of the dense forest. Here, tiny water droplet in the mist scatter light. The color of the scatter light depends on the size of the scattering particle. Very fine particle is scattered mainly blue light, while particle of larger size scatter light longer wavelength. This the size of the scattering particle is large enough, then the scattered light may even appear white. So this is the required answer. Thank you very much.